Hi, my name is Ali Shesavar from Breacher Digital. In our previous video, we talked about how noise gets from one part of the PCB to another with capacitive coupling, and in this video we're going to talk about inductive coupling. Okay, so to understand inductive coupling of noise, let us first have a look at a transformer. Let us say that we have a simple transformer. That's my primary winding. That is my secondary winding. For simplicity, let us say that the secondary is open, and I'm going to call this V secondary, the voltage on the secondary, if I pass a current I primary through this coil. We know from school level physics that V secondary is equal to 2 pi f, the frequency, times the mutual inductance, I will explain that in a moment, times primary current. Okay. The mutual inductance is a function of how tightly these two coils are coupled. In other words, how well the magnetic flux on this primary coil links with the secondary coil. And as a result, we get some voltage that we will see on the secondary side. You can see from this equation that if I halve my mutual inductance and I double my frequency, I will get the same amount of voltage. And let us say now that I will get this transformer and I start unwinding the coils on both sides. As I unwind these coils on both sides, this mutual inductance will get lower and lower and lower. But if I proportionally increase my frequency and make frequency higher and higher and higher as I'm reducing the mutual inductance, this voltage is going to stay the same. Now, let us push this to an extreme whereby I only have one winding. So I have got one winding on the secondary, I have one winding on the primary, they are very close to each other. This is exactly like two PCB tracks next to each other on our PCB. The mutual inductance is tiny, it's very, very low because there is no real winding, there's no magnetic core. However, there is some mutual inductance, and if the frequency gets high enough, there will be some coupling. And if you pass a high frequency current from this side, you will see a voltage on the other side. And of course, this is the noise that we don't want, and it's being coupled with a method of coupling that we call inductive coupling. So what we're going to do next is we're going to go to the lab and we're going to show exactly this using the Bode 500. So I'm now here in my lab setup and we're going to show noise coupling via inductive coupling, right? So I've here a loop of wire, imagine just a PCB track, is connected to my Bode 500 and a signal of varying frequency is being injected into this loop. And this here, I've got my second loop of wire, and when I put these together, effectively I'm forming a transformer, and that'll be exactly the same as having two PCB tracks right next to each other. So what I'm going to do is I'm going to put these next to each other. Let me clamp them so that they don't move very much. And then we look on Bode Analyzer Suite, and here you can clearly see the gain of the signal of this setup. What is happening here is that the Bode 500 is injecting a signal and is looking at the size of the signal that's being picked up by the second, let's say, PCB track. And at 500 kilohertz it's sending a certain size of signal, and you can see that at 5 megahertz the difference is 20 dB. So the size of the signal that's being coupled is going up at the rate of 20 dB per decade. Of course, I can see that on the oscilloscope, and you can see that as the frequency goes up, the sign of the sine wave that is coupled, this is noise, gets bigger and bigger and bigger. So let's have a look at that. I'm going to try and do that without messing up my measurement setup. There we go. So let us now go and have a look at the oscilloscope. And here we are. You can clearly see that at low frequencies, the size, the amplitude of the signal that is getting picked up by the second PCB track is small. And of course, as the frequency goes up, that gets bigger and bigger and bigger. And of course, this is inductive coupling. So I hope you enjoyed the video. We run regular workshops on EMC and power supply design. I hope that you can join us in one of these, and thank you very much for watching.